What causes a solar eclipse? A solar eclipse is a celestial event that occurs when the moon passes directly between the Earth and the Sun, casting a shadow on Earth and partially or completely obscuring the Sun's light in certain areas. This phenomenon captivates observers around the globe and has been a source of wonder, curiosity, and even fear throughout human history. Understanding a solar eclipse requires an exploration of the astronomical mechanics behind it, the different types of solar eclipses, the conditions that make them possible, and their effects on Earth. The mechanics of a solar eclipse. A solar eclipse occurs due to the alignment of three celestial bodies: the Sun, the Moon, and the Earth. The Moon orbits Earth in an elliptical path, and its plane of orbit is slightly tilted, about 5 degrees, relative to the Earth's orbit around the Sun. This tilt is why solar eclipses do not occur every month during a new moon phase, even though the Moon passes between the Earth and the Sun regularly. For a solar eclipse to happen, the following conditions must align. 1. New moon phase. A solar eclipse can only occur during the new moon phase, when the Moon is positioned between the Earth and the Sun. 2. Nodal intersection. The Moon's orbit intersects Earth's orbital plane at 2 points known as nodes. A solar eclipse occurs when the new Moon is near one of these nodes, allowing the Sun, Moon, and Earth to align in a straight line or nearly so, a condition called syzygy. 3. Proximity. The Moon must be close enough to Earth in its elliptical orbit to fully or partially cover the Sun's disk. When these conditions are met, the Moon casts two types of shadows on Earth. Umbra, the darkest part of the shadow, where the Sun is completely obscured. Penumbra, the lighter, outer shadow, where the Sun is only partially obscured. Types of solar eclipses. Solar eclipses are classified into 4 main types based on the extent to which the Moon covers the Sun and the specific alignment of the celestial bodies. 1. Total solar eclipse. In a total solar eclipse, the Moon completely covers the Sun, revealing the Sun's outer atmosphere, or corona, which is otherwise invisible to the naked eye. Observers located within the path of totality, the narrow region on Earth where the umbra falls, experience a brief period of darkness during the day. Total eclipses are relatively rare because they require near-perfect alignment and the Moon to be at a point in its orbit where it appears large enough to cover the Sun. 2. Partial solar eclipse. A partial solar eclipse occurs when the Moon only partially obscures the Sun, leaving a crescent of sunlight visible. This type of eclipse is more common and can be observed over a much larger area than total eclipses. However, the Sun is never fully covered, so the dramatic effects of a total eclipse, like the corona's appearance, are not visible. 3. Annular solar eclipse. An annular solar eclipse happens when the Moon is too far from Earth in its orbit to completely cover the Sun. As a result, a ring of sunlight, known as the ring of fire, remains visible around the Moon's edges. This occurs because the apparent size of the Moon is smaller than that of the Sun due to the Moon's distance from Earth. 4. Hybrid solar eclipse. A hybrid solar eclipse is a rare combination of total and annular eclipses. Depending on the observer's location along the eclipse's path, the event may appear as a total eclipse in some areas and an annular eclipse in others. This phenomenon occurs due to the curvature of Earth and the varying distances between the Moon and different points on Earth's surface. The role of orbital dynamics. The occurrence of solar eclipses is governed by the complex interplay of orbital dynamics. 2 key cycles influence the timing and frequency of eclipses. 1. Saros cycle. The Saros cycle is an 18-year, 11-day period during which similar solar eclipses repeat. This cycle arises due to the synchronization of the Moon's orbit, Earth's orbit, and the alignment of the nodes. Eclipses separated by a Saros cycle share similar characteristics, such as geometry and duration. 2. Metonic cycle. The Metonic cycle, spanning approximately 19 years, is another important period in which the phases of the Moon repeat on the same calendar dates. This cycle helps predict when solar eclipses might occur over longer timescales. Please like the video and subscribe the channel. Observing a solar eclipse. Watching a solar eclipse is a breathtaking experience, but it requires careful preparation to ensure safety. Observing the Sun directly, even during a partial eclipse, can cause serious eye damage. Special eclipse glasses or solar filters are essential for safely viewing the event. Pinhole projectors and telescopes equipped with solar filters are other popular tools for eclipse observation. During a total solar eclipse, observers within the path of totality can safely view the sun's corona with the naked eye when the sun is completely obscured. However, this period of totality lasts only a few minutes, depending on the eclipse's specific conditions. Solar eclipses and their effects. Solar eclipses have both scientific and cultural significance. In the scientific community, eclipses provide unique opportunities to study the sun's corona and other phenomena. Observations during eclipses have contributed to significant discoveries, such as confirming Albert Einstein's theory of general relativity in 1919. Culturally, solar eclipses have inspired myths, legends, and superstitions throughout history. Many ancient civilizations viewed eclipses as ominous events, associating them with gods, spirits, or cosmic battles. Modern understanding has demystified eclipses, transforming them into awe-inspiring natural events that unite people in shared curiosity and wonder. Frequency and rarity. Solar eclipses occur at least twice a year, but not all are total eclipses. The rarity of total solar eclipses in a specific location arises because the moon's shadow covers only a narrow path on Earth's surface, and this path shifts with each eclipse. On average, a particular location experiences a total solar eclipse once every 375 years. Conclusion: a solar eclipse is a testament to the precision and beauty of celestial mechanics. It serves as a reminder of the intricate relationships between the sun, moon, and Earth, as well as the profound impact of these cosmic events on our understanding of the universe. From the mesmerizing sight of the sun's corona during a total eclipse to the scientific breakthroughs enabled by eclipse observations, this phenomenon continues to inspire humanity, bridging the gap between science and wonder. Please like the video and subscribe the channel.